Hey everyone! Today we will learn how to create a simple application using Spring Boot. Before we begin, I would like to tell you guys that we have daily updates on multiple technologies. If you are a tech geek in a continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon. So without further ado, let's directly dive into our agenda for today's discussion. Today we will discuss the Spring Boot fundamentals and we'll learn to create an application using Spring Boot. We have Vikesh, an experienced software developer with a strong grip on Java programming language. Vikesh will be taking us through the Spring Boot session for today. Over to you, Vikesh.
Hello guys, this is Vikesh and let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please you can read about the RESTful concept. As a concept, what does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc. etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_myLift template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application.run and you supply application.class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller But this time it's not a web controller, but it's a REST controller. So you see in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot: run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot, and this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment. Let's get started with our demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see this how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, you in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application, and then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from Java X persistence entity, and this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java X persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here, but I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you will see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto-word annotation and will automatically supply an object whenever it is required. Then I have two methods here since we are talking about HTTP endpoints. So I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation. And then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well. And then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why at the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080 with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost/student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. and let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here, and in the student controller, it is going to hit the get student method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP get method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want. And that's all I want to cover in this particular lecture. Thank you, and we'll meet again in another session.
Thank you, Vikesh. It was a wonderful session. With that, we have come to an end of this session on Spring Boot. I hope this session was informative and interesting. If you have any queries regarding the topics covered in this particular tutorial, then please feel free to ask them down in the comment section below. Our team of experts will be happy to solve all your queries. Until next time, stay safe and keep learning.